Okay, so we're going to be talking about arithmetic sequences. And the good news is you have been working with arithmetic sequences for a very long time, because when you look at these, you're going to find out that it's actually something you've worked with since at least 7th grade. So let's take a look at a arithmetic sequence. So hopefully everybody knows what a sequence is, right? It's going to be this ordered list of numbers, basically. Arithmetic, of course, it sounds like the word arithmetic. It's going to be dealing with adding and subtracting. So let's take a look at one sequence that we might encounter something like this. Okay, so these are the first 1, 2, 3, 4, 5 terms of my sequence, and this one's going to go on with my little dot, dot, dot there. It's going to continue on. So there's lots of things that we can be asked to do with arithmetic sequences, but they're all going to have this things in common. So let's take a look at this sequence for a moment. Hopefully, if I asked you what the next number in the sequence was, you would automatically right away be thinking that it is 13. And of course, why did you know that right away? Well, most of us see this right away, and you see that these are all going up by 2, right? So to get from here to here, we were just adding 2 every time, so it makes sense that the next one is going to follow that same pattern and be a plus 2. Now, in a sequence, we don't know that that's true unless we knew that this was an arithmetic sequence. Maybe this was, it could be something different, but since I was told that it's an arithmetic sequence, I actually know that that's true. So usually they ask you to find the most probable one also anyway, so that would be the best guess for this one, no matter which way you were going. Okay, even if they didn't tell you it was arithmetic, 13 is probably the right answer here. Okay, so this is what makes it an arithmetic sequence. It's because it's going up by the same amount every single time. So if I had another sequence, something like, I don't know, something like this one, this would also be an arithmetic sequence, because of course this one is going, I said going up, but we should say, I'm going to actually say, I'll say going up by a negative 10, right? Each of these is going up by negative 10, or in other words, we're subtracting 10, we're subtracting the same amount from each term, right? So this guy is an arithmetic sequence too. Now this number that it goes up or down by each term is called the common difference. And we call it a common difference because, of course, it's the difference between 2 consecutive terms. And so difference in math is subtraction, right? So if you had 20 minus 10 here, you would get the 10, right? So the common difference here is 10. Make sense? Actually, what we should do is do this way. 10 minus negative 10 is 20. So the difference between this term and this term, I guess, makes more sense, right? So we're subtracting this number from our term to get the previous term. And the same would be true here. 5 minus our common difference here is 2 would give me a 3. Okay? So that's easy enough. So what kinds of things do we use these sequences for? Well, you've actually already modeled a ton of stuff with these kinds of sequences. So let's take a look at maybe coming up with a model or an equation to represent these sequences. So we'll go back to our first sequence. We'll use this one. Okay, just because. Why not? And let's come up with a model or equation. So sometimes they'll use the word model. They'll say model this a model this sequence, or write an equation for this sequence. There's all kinds of ways we can do it. Now, I've seen lots of different ways that they kind of approach this in textbooks, but I think that the easiest way to think about it is the way that you've already learned and you're very familiar with. So what I'm going to do is I'm going to think about it this way. I'm going to think about it as the term number and then the term. So I'm going to set it up like a little table. Maybe this will help you see what I'm talking about. So the term number, this would be my first term. So I'm going to call that term number 1. My second term, my third term. See where I'm going here? And then I'm going to use these as my terms, right? So term number 1 is a 3, term number 4 is a 9. We said that term number 6 was a 13. Okay, so let's take a look at this. If I were to graph this, what would it look like? 1 would have a 1, 2, 3. 2 would have a 1, 2, 3, 4, 5. 3 would have a 1, 2, 3, 4, 5, 6, 7. Hopefully you can see from just these few couple of points that we have a line. So the kind of equation that we'll be using to describe this sequence will be a linear equation. You know how to write the equation of a linear equation. You know how to write the equation of a line, right? So let's take a look at this. How would you write the equation of the line? What do you need to know? Hopefully everybody is screaming out slope. You need that for a line. And what else do you need? You need a point. All right. Now there's two ways we could go about this. We could use a very specific point. We could use the y-intercept, which is one that we like to use a lot, right? Or we could use our point slope form. So there's two ways that we could go about writing the equation of a line. And hopefully you're familiar with both of these. So one form that we like to use is this one, our slope-intercept. Of course, what do I need? I'd need the slope and the y-intercept. But hopefully everybody's sort of familiar with this one too, where we have x minus x sub 1. And actually this one we use a lot, or I use a lot when we're doing calculus or other things. I think that this one is oftentimes an easier form to use because we don't always have the y-intercept. Sometimes we just have 2 points. And so we could always use this form. And hopefully you know that this is point slope. And of course, if you can't really remember a point slope or it doesn't feel familiar to you, just think about what slope, the formula for slope is. It's the difference between y over the difference between the x's, right? So it's change in y over change in x. And then if you just multiply this guy by the x's on both sides, you basically have, or not basically, exactly have your point slope form, right? So it comes directly from the idea of slope. It's just the slope formula rearranged a little bit, okay? So this one's really easy to remember and really easy to use in a lot of cases. This one is usually okay to use, and since we're pretty good at doing linear equations or working with linear equations, it's usually not a problem. So let's talk about this one. I'm going to write the equation for this one. We'll do this one first, and then we'll take a look at this one just so everybody knows how to use it in case you're not too familiar with it. So let's do the point slope one first. I mean, not the point slope one, the slope intercept, because that's the one probably you're most familiar with. For some reason, people don't like to work with him very much in the younger grades, but like I said, you're going to see that he's your best friend later on. All right, so let's take a look at this one. So how do I find slope? Well, we just said slope is the change in y over change in x. And what did I use as my x values for this graph? I used my term numbers, right? These were the term numbers, 1, 2, 3. And what did I use for the y? So these are my term numbers. I call it term numbers. And then this one is the actual term, or the term value. So when I write the equation, he's going to be my function value, right? So let's take a look. In order to find the slope, if it's change in y over change in x, well, these guys are the y's. Well, what was our change in y? We just saw that when we did this guy here. The change in y here is your common difference. Do you see that? So this is going to be a 2. What's our change in x? Well, this is a 1. So my slope here is, of course, 2 over 1, which is just a 2. And everybody knows, of course, since it's a ratio, that I could also go all the way to here. You know, I could pick. So this change would be a, how many? 3, right? And then this one would be 9 minus 3 would be a 6. And you can see that that ratio stays the same, right? That's what makes it linear. It goes up by a constant rate here. Now, the only other thing that we need to know is where is it going to cross this y-axis, right? We need to know this point if we're going to do point-slope form. Not point-slope, slope-intercept form, right? If we're going to do slope-intercept form. So how do I find that? Well, there's a couple things I could do. I could set up my equation and put the slope in, and then put in an x and a y value. So just pick any x and y you want. So if x is 5, that means y has to be 11. So this would be 10 plus b is equal to 11. So hopefully you can see here that b is equal to 1. Or since I'm already starting at the first term, right, what I could also do is just kind of go backwards a little. What would it be when x is 0? Well, use my common difference the other way. That would make this a 1. Right? So everybody here can see that my y-intercept is a 1. So now we're ready to write our equation. That's all we needed to know. So it's 2x plus 1. It wasn't anything that I didn't already know how to do. We've already done these a million times in algebra 1 and 2 and probably even pre-algebra. You've been doing them a very long time, right? All right, now let's just take a quick peek at this other form that we see here. So our point-slope form. So one way that we can write this equation, because everybody knows that there's many different ways that you can write the same line. They'll all be the same equation if you were to simplify them or whatever. You can rearrange them to look the same, but you can rewrite it in a bunch of different ways, make it look different, right? So let's look at this point-slope form. So what does this one tell me to do? Well, this one says take the slope, which we already said, that's easy to find. Change in y over change in x, that's going to be our 2. And then pick any ordered pair we want. It doesn't have to be this one. So I'll choose this one that I chose before. So what is that one going to be? It's going to be minus 11 minus 5. Okay? Now this would be a perfectly acceptable answer for the equation of this sequence. If it doesn't ask you what form to put it in or doesn't give you any rules about how you can write it, you can write it this way. But again, most people probably are thinking this in their head. But just to show you that it's going to come out the same, let's just take a quick peek. If I distribute this, now you can see, obviously, it's the same exact equation. We just wrote it a little bit differently, right? So when you move the 11 over here. Okay, so you can use either form. Again, if it doesn't tell you specifically, of course, a lot of the times you are looking nowadays, of course, with the online, especially at multiple choice things. So if it's multiple choice, they're probably going to write the answer something more like this. If it's open response, I would definitely take that as an answer. That's fine. It's an equation for that sequence. All right. So let's just take a couple of questions here that you might see on maybe a homework assignment. So let's take a look at this one. This one says, write the first 5 terms of the arithmetic sequence. So arithmetic is the noun, arithmetic is the adjective. So this is describing the sequence. All right, so sometimes people think I'm just saying it funny, but that's actually how you use the word arithmetic as an adjective, right? All right, so this one, there's a couple ways you can get this one done. You know the first term of the sequence, and you know that the common difference is 6. So obviously, one easy way to do this is just to keep adding 6 every time, right? And keep going until you get 5 of them. That's one way we could go, right? That makes perfect sense. So what would the next one be? It would be a 23, and the last one would be a 29, right? If that would be the first 5 terms of the sequence. Easy peasy. Same with this one. I can just kind of find the first 5 terms by just using addition and subtraction. So one way we could go, if you know that the 8th term, so what is this little, that's what this little symbol means. I guess I should point that out. A sub 8, we read that A sub 8 means the 8th term. A sub 1 means the first term, right? A sub n is what we use usually for the generic term. Oh, and so just so that you know, so I was saying how sometimes the textbooks will write it a little different. Let's just go back here now that we've talked about A sub n. It's still this idea of this model, but they sometimes will write it as something like A sub n, so the nth term, where these guys are the outputs, right? And n will be the input. We have the slope, which is the same thing as the difference, and it will be, I don't know, they do, I guess they would do this. Something like this. Well, actually n, right? Because we're using n, not x. So they would do something like this. And what is this? This is the y-intercept because it's the first term minus the difference. Do you see that? And that's actually how we found this y-intercept, isn't it? We took the first term and we subtracted the difference, and that's how we found the y-intercept. So this is the difference times, you know, the number of terms that you want to get to. So this would be n, and this would be a sub n. Okay, so you'll see something with all these d's and a's. It's actually the same thing as what I'm talking about here with these x's and y's, where this is the term value or the y value. I was calling it y, and this is the term number. I was calling it x, and this is the y-intercept. So it's actually the same exact form. It's the same exact equation as this one. Okay, so let's take a look back at this one now. So we have a sub 8 here. So, you know, of course, one way that I could do it is, if this is the 8th term, I could just go backwards and, you know, start subtracting 42 from each of these, right? So this would be 26 minus the 42. This one would be the 26 minus 2 of the 42. Right, you could keep doing that and just go backwards and find all the numbers that way. The other way you could do it is just write the equation of this. Since we already know how to find the equation of this, we could just say, and since this one is just two terms, but I don't have the, you know, the 0th term or the y-intercept term, I'm just going to use this form. I'm going to use my point slope form. Or in other words, if I was writing it, as I guess I should say, if I'm writing it as my generic one, it would be like this one. Okay. I guess this would be 1. So I don't really like to write it that way. I think it gets too confusing, so I'm just gonna, just so people know what I'm talking about, let's go with this one. All right, so again, these are standing for my y's, and these are standing for my x's. So if I have 42, so I have y minus 42 is equal to, well, what I really need to figure out here is my slope, so that's going to be my change in y. And how do you find the change in y? You do the difference. That's how you find change in math. You subtract. And then we have 12 minus 8. So what's that? 2, is that a 12? 12 over, and what is this? This is going to be a 4. And then we have our x minus, well, we have, I used the 42, so we have to use the one that matches, which is this one. So we have y minus 42 is equal to 3x minus 26. And now all you would have to do to figure out, you know, the first term or the 5th term, whichever term you wanted to know, just plug in, you know, the right number. So if you wanted to know the first term, you do 1 minus 26, y minus 42, and you could figure out what your first term is, and then you could add your difference each time if you wanted to go that way, right? So that's one way that you could go. All right, now let's just look at these ones down here. And this time, instead of writing the first 5 terms, why don't we just find the formula, since we're getting towards the end here. So let me just fold these so we can go right down here. So find the formula of the sequence. Again, very simple if we have these ones. There's 2 ways I can do it. I know I'm going to need to know the a sub 0 term, or in other words, the y-intercept if I want to use this one. What are we going to do? We're going to subtract 3 from this, so it would be a -2. So this one would be y is equal to, well, our slope here is 3, x minus 2. And again, if you want to put it back in our sequence terms, well, this would be a sub n is equal to 3 times n minus 2. Okay. If you wanted to use your point slope form, it would be y minus 1 is equal to 3, x, and this is actually the first term also, this one. And again, if you wanted to put it back in these terms, remember, what are we using for y? We're using a sub n. And what are we using for x? We're using n. So you could also rewrite it that way, or whatever. You know, it doesn't really matter which way you think about it. All right, so let's look over here. Now this is a perfect example where this form makes a lot more sense. So I'm going to do that one first. So it's going to be, I'm going to use this set of terms. It doesn't matter which one I pick. I could use either one, but if I use this one, it's going to be y minus 190 is equal to, well, now I need to actually find my slope, right? So it's going to be 115 over minus 190 over 10 minus 5. And once you know what that slope is, we can, so this will be minus 5. So 115 minus 190, obviously it's going to be negative. That's going to be a 75. And this is going to be a 5. So that makes it just a negative 15, right? So there's my equation. So that's one way we could go. Again, open response, if you're doing your homework and you're just doing, whatever, this one's fine. So again, if you wanted to use this set of points, what would it be? It'd be y minus 115 is equal to, well, we have the same slope, so it'd be x minus 10. Or if you want your slope-intercept form, and again, if you want to change them to the a sub n, so you would just change this to a sub n minus 190. Negative 15, n minus 5, same thing here, just change them to a sub n. Now, if you want your slope-intercept form, of course, that's pretty simple. It would be negative 15x minus 150 or plus 150. And then just add 115 to both sides. Is that 265? So there you go. And of course, how else could you do it? You could have plugged it into here, put in the x and the y and the slope, and then figured out what b was. You could have done it that way also, right? So any way that you can get to there is fine. And again, I just think of it as a linear equation. I don't bother to try to memorize all the other formulas that they give you in the textbook, because I think you already have the information to do it, and it's much easier to use what you already know than to try to memorize something that's kind of irrelevant. Okay? So there you go. Get going on your arithmetic sequences.